Dear students, in this video we are going to see the third module of Advanced Microprocessor and Embedded System based on CuSAT syllabus. So as you all know, this syllabus is for S5 CSE. And coming to the syllabus, in the module 3 we can see Introduction to Embedded System, Typical Embedded Systems, various characteristic and quality attributes of embedded system, embedded system with its application and domain specific, designing embedded system with 8-bit microcontrollers, and it includes programming with 8051 microcontrollers. So in this video we are going in detail regarding introduction to embedded system. So without knowing embedded system concept we won't be able to go further. Okay, so this video will be fully focusing on introduction to embedded system. Before going in detail regarding the embedded system, let us go through and understand the concept of system. So what is a system? As you all know, in each and every place there is a system of work, there is a system of settings. So what is meant by a system? Actually, system is defined as a set of rules based on which the subsystems will work. So here we can define a system as a way of working, organizing or doing one or many tasks according to a fixed plan or a set of rules. And it is also an arrangement in which all the units are assembled and work together according to that particular plan. Consider the case of a time display system. We are all using watch, right? So what this watch does? It displays the time, right? So we know the components of watch includes hardware, needles, battery, dial, chassis and strap. And this all watch display system is having a specified role, right? And this individual parts, what they do, they will work together based on certain rules in order to perform a specified function. Now comes the introduction to embedded system. So as you all know, our daily lives increasingly rely on embedded systems which is found in everyday appliances like refrigerator, whatever it may be, washing machine, vehicles, and these intelligent systems, they manage everything from headlamp and engine control to airbag deployment, enhancing comfort and safety without user even realizing that. And these hidden computers are known as embedded systems. These embedded systems are intelligent systems that make our life easier and simpler. Despite their crucial role, embedded systems work silently in the background with somewhat like a loyal servant. So what is an embedded system? An embedded system is an electronic, or it can be said as an electromechanical system, and it is a combination of both hardware as well as the software, which is designed to perform a dedicated task. And it has only one application software and is embedded in the ROM only, read-only memory, and it does not need any secondary memory in computer because it is being embedded in ROM itself. An embedded system means the processor is embedded in that application itself. An embedded product, it uses a microprocessor or a microcontroller to do a specific task. And this embedded system can be considered as an information processing system which is embedded into the larger product. As you all know, every embedded system is unique and the hardware as well as the firmware is highly specialized in the application domain, and they are becoming inevitable part of the product equipment in all fields including household, telecommunication, medical equipment, industrial control, consumer products, whatever it is. Certain examples are cell phones, automatic washing machine, traffic signals with timers, automobile electronics. In simple terms, an embedded system is an intelligent electronic circuit or device that has the following three parts: input, controller, and output. And the major characteristic is that they are task specific and they perform a single task within a larger system. A mobile phone is not a single embedded system. It has a variety of embedded systems that can perform display, charging, sound, etc. Together, they can form a general purpose device. Here comes the comparison of general purpose as well as the embedded system. So coming to the purpose, general purpose computing system, they are built to handle a variety of applications as well as the needs of users. But coming to the embedded system, they are designed for a specific dedicated function. When it comes to the flexibility, general purpose computing systems are highly flexible and users can install and change the software. But in the case of embedded system, they are rigid and thus runs on predefined software with limited changes. Coming to the hardware and OS, usually this general purpose computing system, they uses general purpose hardware with standard OS like Windows or Linux. But embedded system, it uses specialized hardware and may run on lightweight or no operating system. Coming to the power and performance. So the general purpose computing system prioritizes performance, less concern for power efficiency. But embedded system, it balances performance with strict power and resource limits. And the examples for general purpose computing systems include laptop, desktop and servers, and embedded system includes smart appliances, medical devices, automotive controllers. Then comes the classification of embedded system. So embedded system is categorized based on various features. First category based on generation. Embedded systems are categorized into generations reflecting technological advances, which includes first generation, second generation, third, fourth, etc. And the first generation includes simple systems that uses 8-bit or 16-bit microcontrollers. And the second generation, it includes more powerful systems with embedded OS, example SCADA. And the third generation, that is, it came as a domain-specific controllers like DSP or ASIC merged. And in the fourth generation, that is a SoC system on chip, multi-core processors, real-time systems in smartphones, etc. And what's next? The future systems expected to be smarter and more integrated. Based on the complexity and performance, embedded system can be divided into either small scale, medium scale, or large scale. Small scale means it is a simple and low cost system, for example, which is the case of the embedded system that is found in the electronic toys. Medium scale. It is having a moderate performance compared to the small scale with basic OS, like example 16 and 32-bit systems. When it comes to the large scale, it is a high-end system with reconfigurable SoC, multiple processors, and real-time OS. Based on the deterministic behavior, embedded system can be either hard real-time, which is having a strict time constraints like airbag systems in car, and another one is soft real time. Here timing is important but not critical. Example video streaming. And based on the triggering mechanism, there are two types of embedded system, event triggered and time triggered. In the case of event triggered, it is activated by specific events like sensor signals. In the case of time triggered, it is operated based on scheduled time intervals. Coming to the application specific customization, embedded systems are optimized for specific applications like medical devices, robotics, or industrial control, balancing performance, cost, and power needs. So, if you consider the example of application specific embedded system, one example is like gadget with we know that sports tracker shoes is there, right? So it may be Adidas brand. So over there, whenever it is having certain monitor or sensor devices that can track the number of steps and rest all parameters within the shoe itself. So that is one example of application specific embedded system. Okay, that is integrated in a particular device, like here that sensors are integrated in the shoes. in order to track those parameters of sports personalities. Now, when it comes to the application of embedded system, there are various applications like consumer electronics, includes camcorders, cameras, etc. Household appliances like TV, DVD, washing machine, refrigerator, microwave, ovens, etc. Home automation and security systems, including AC, sprinklers, intruder detection alarm, CCTV cameras, fire alarms, etc. Automotive industry, ABS, engine control unit, ignition system, automatic navigation systems, etc. And telecommunication, which includes cellular phones, telephone switches, handset, multimedia applications, and many more. Computer peripherals, computer networking systems, healthcare, measurement and instrumentations, banking and retail, card readers. So the applications are many and it is not fixed to this particular specific set of applications. Coming to the purpose of embedded system, basically embedded system is used to collect the data, either collect the data, gather the data, store that and present the data in the usable format. Then transmit that particular data that comes under data communication. Then comes processing the data, that is process raw data into meaningful information. Then observing those data, that is monitoring and tracking these parameters in real time. Then if there is any behavioral changes in this particular data, we need to control those data. So there comes control, and if it is okay, we will deploy it into a application specific user interface. So these are the purpose of using embedded system. Thank you.